This is part two on the series of digitizing a graph. I kind of pulled a fast one on you. I actually went in and used the previous version of the points that I'd put together. I did a little better job earlier. I did it kind of fast when I went through the video, so I've kind of done a little bait and switch here. So I've recreated everything using the previous values that I've done, but we're kind of at the same point where we left off on the last time. So let me just show you. So we've got input here. Basically I just put in the previous version that I did that I didn't really show you, I started out with header files. So I wrote into the file a header called X, general shear, and various things. So let me show you what that looks like as I pull this up. So I double click the body of the spreadsheet. And should open up here in a second. There we go. Okay, so you can see I actually created these headers across, and I did it just by writing into the input area of the screen. So since these are strings, because they're in quotations, excuse me, they just wrote them into the upper part. So I wrote XGS in the cell A1, YGS in the cell B2, etc., etc. So again, you can close these out if you don't want to show them. I'm going to leave this open. In the last video, I showed you how to output data. So let me close this. And then I've got this extraneous area that I'm just going to hit the delete key until I get it out of the way. So if I type in XGS and hit the equal sign, then you can see that there's the data that I was pulling up. Let me take a second just to show you how to do some stuff with matrices and vectors here. So if you go to matrices, vectors, here's a list of functions that you would use. Let me look at some of the most common ones. One of them is what is the index value of the last item in the vector of the matrix? And then there's another one called length. Let's go with XGS. And they're the same, so why would they have two? Well, let's go up to the calculation. And you can see right now my origin is set to 1. If I change the origin to 0, okay, then the index of the last value is 13, but the number of values is 14. So that's pretty important. So a lot of times in a Mathcad template, whether or not the origin is set as 0 or 1 is really important. So in a lot of worksheets, you probably need to check that if that's important. So the way you can do that is that you can write a little program that says, okay, if you need it to be the origin is 1, then you set the last and the length equal to each other, and if that's true, then you're in the right origin. If it's not true, then you may need to switch it. So so you can output some of that. So that's one of the important things. The other thing is that you can change the number of items that are being shown just by clicking and dragging. Okay, so I can make this smaller for presentation purposes, especially if you have a matrix of hundreds of different values. You don't want to take a page after page after page of showing them. So you can make that bigger, smaller as you need to. If you want to know the number of columns, you can type columns and hit the equal sign. It says, okay, I got 1 column. And if you want to know the number of rows, okay, that's kind of the same thing as the length. If you want to know the largest value in the column, type in max XGS. Okay, that's 1, which is down at the bottom. And if you want to know what the minimum value is, then you can use the minimum function. There's other things you can do Uh, so for example, let me get some room here, and let me just make an arbitrary matrices. Let's say I want 4 numbers, and let's just do them 1, 5, 3, 6. Okay. If I want to get those in ascending order, then I can use the sort command and hit equals, and it sorts them from lowest to highest. Well, what if I want it in the opposite order? Well, you can do the reverse sort, E sort, parentheses, M equals, and it sorts them in reverse order. Okay, that's very handy. Let's look at something else. So if you had a multi-column matrix, so example, let me create another one, call it N, and let's make this a 2 by 4 matrix, 2 columns, or it'd be 4 by 2, 4 rows and 2 columns. Let's say 1, 5, 3, 2, 8, 9, 2, 3, for example. Then I can use this csort command, which is column sort, and I can sort by the first column, the equal sign, and you can see that, okay, it's, so if I go back up in my calculation, since my origin is set to 0, then the first column is actually the second column because the first one is 0. So let me switch that, and then that's kind of the way you would expect it to look depending on what the origin is. And I can also do a reverse csort. Reverse, hit the left parentheses. I'm going to type in csort, hit the left parentheses, type in N, and then I'm going to sort it on column 2 this time. And you can see that it sorts column 2 from from highest to lowest. So these are just some of the different things you can do with vectors and matrices in Mathcad. So let me delete all this stuff. Okay, so let me just type in. So I got XGS, YGS equals. I've got XLS equals, and I've got YLS equals. So this is my data right here that I pulled from the AutoCAD digitization that I made. Okay, and so then I actually got Excel to do a polynomial fit, and I've got it to output the regression tables and the R-squared coefficient, which tells you something about the goodness of fit. And there's many other ways of doing that. So I want to look at about 4 different ways that Mathcad can do curve fitting. So I'm going to look at a polynomial, we're going to look at an exponential fit, a power curve fit, and what's known as a locally weighted regression analysis, or LOESS, LOS. And when I send this out, I'll send you out a paper that I found on the LOS function. It's pretty handy. I like it a lot. I've done some things using the LOS function. Excel, in one of its recent iterations, incorporated the LOS function into Excel. It's becoming fairly popular way of doing curve fitting, and so we'll talk about that just a little bit. So the first thing I want to do is I want to talk about a curve fitting technique called polyfit. Okay, so this is a polynomial fitting. So the one thing I want to do is I want to tell it, well, how many different polynomials do I want? And let's say 6. And I'm going to go ahead and set a range for x. So I'm going to say x is equal to 0.001. So this will give me a nice smooth curve. And all my curves here, to mimic or to fit the punching shear curves, the x value, the domain only goes up to 1. So that's all I need to do. So I'm going to write a function. I'm going to call it f, and I'm going to call this polyfit. And I got to find it. Thought it was here. No, it's not under solving. Curve fitting, design of experiments. There it is. Polyfit. All right. So it's going to give you some arguments. So I'm going to give it the x values that I'm looking for. I'm going to give it the y values that I'm looking for, and I'm going to tell it how many different polynomials I want. All right. So now let's graph this stuff. Let's go in and do a chart component because I want some control over what's going on. So let's pull it up. So now I need to input. I'm going to input the raw data, the data that I got from AutoCAD, and then we're going to look at some of the curves. So let's plot the raw data first. So I'm going to right-click my mouse. I'm going to insert an x expression. I'm going to call it XGS. Then I'm going to insert the y value. I'm going to call that YGS. And I should get a plot. There we go. Now I've got a plot of those points. Let me, it's set up as a line. So let's change it into, here's my trace. Instead of a line, let's change it into symbols. And let's try circle. There we go. And close it. So now you can see that I plotted this. This is the raw data that I got from AutoCAD. So now let me plot the function that I just did. So I'm going to insert an x-axis. So I'm going to call that x. And then I'm going to insert this polyfit on the y, and I'm going to call that f of x. Let's see if that plots. There we go. So why does this look so funky? Well, my domain is a little wonky. So I only want to go from 0 to 5 in this direction. So let me fix this just a little bit. All right. So my x, let's just take a look at the setup. So it goes from 0 to 1 in 5 steps. That's okay. Let's look at the y. Setup. Well, here's my problem. It goes from minus 2,000 to 16,000. So that's not really what I wanted. I wanted a minimum of minus 5, and I want a maximum of 0. Okay, and let's see, the steps that I want are probably, let's say 5. Yeah, that looks a lot better. All right, let's put some grid lines in it. I like solid grid lines. And let's go on the X and put some grid lines on there. And again, I like the solid ones. All right, so let's go back to my graph. All right, so you can see that that's pretty good. That's a pretty good curve. I've got a polynomial that looks like it fits pretty well. It's got 6 different coefficients for the polynomial. So that means it's raised to the 5th power, if you will. So that looks like a pretty good fit. So I could be done here. And the nice thing about this is that let's say I wanted to evaluate f at a point. Let's say point 8. Well, that tells me exactly what it is. So any place I want to interpolate this, I'm done. And that's one of the advantages I think this has over Excel. So in Excel, when you get that little regression equation, you have to program it in so that you can do some interpolation. So it takes some extra steps. But let's say that, let's say we wanted to compare. Well, let me go ahead and add let me go ahead and add some other data in here. So I fitted the first curve. Let me make another function. Let's call it h. I'll tell you what. Let's change this. Let's change this to GS, general shear function. And that means all this is messed up. So let's change that to GS. And let's change this to GS. There we go. So now we're back. So let's call this other function LS, which stands for local shear. I'm going to use my functions. I'm going to go into design of experiments. I'm going to use the polyfit. I'm going to type in XLS. Hit my right arrow key a couple times. Hit Y. Oops, little YGS. Hit the arrow key and type in N. Gives me an error message. Oh. YLS. There we go. So now if I wanted, let's graph this. I was going to plot a point, but I don't need to. You get the idea. So right click my mouse, select X expression is X. I'll tell you what, before we do that, let's type in XLS, and then, so that we want to plot the raw data, and so this would be YLS, and then I should get a plot. Got the same issue going on. The default wants to plot the data as a line, so I'm going to go back in and change it. Instead of a line, I'm going to go to symbols. I like the little round circles, but let's change the color. Yeah, it's a good wood color right there. So close it. Okay, and now I can go back in and plot my function. Right click, I'm going to say, okay, this is X, and then I'm going to right click again for a Y expression, and this will be LS of X. And it's going to think about it while it runs through the minimization. So that looks pretty good. That looks about the same as the XL curve. Now I could plot the residuals, and I may do that. I may do that here in a second. So and just see how that works out. So there's some other stuff that's available. Let's say that I had somebody that was skeptical and wanted to know, well, what are these coefficients that this black box kind of thing plotted out? Well, I can pull up the coefficients and some other statistics of the curve fitting that I did using polyfit. So I'm going to create a matrix, and I'm going to call it, let's call it M sub GS. And when I hit the sub, I hit control underscore, and to make that a variable, and I'm going to type in polyfit C, which stands for the regression coefficients. Okay, and so I've got some arguments that I've got to put in. So I'm going to put in XGS. I'm going to type in Y sub GS. I'm going to type in N, and that's the only one that I need. So when I hit the enter key here, wow, a lot of this stuff just kind of appeared. So let's unpack some of this a little bit. There we go. So what it's saying is that it's a normal polynomial function in that I've got a first term, which is just a constant. The second term has a coefficient, and then it's raised to the x power. Then I've got another coefficient raised to the x squared power. That's what these little a's mean. And then I have a third coefficient that's cubed, another coefficient that's raised to the fifth power, et cetera, et cetera. Okay, so 4, 5, 6. So it also tells me what it gives me some statistics based on a normal probability function. So if I wanted to know with 95% confidence what the range of my fitting parameters are, this tells me what it is. And then I think T stands for the student T area and some other things I'm not really sure of, but these are the things that I really want to know. Okay, so what I'm going to do now is that I'm going to pull these coefficients out and just double check that everything is right like it should be. So first I'm going to evaluate my function, and my function is gs of x, gs at 0.85. Okay, and so that gives me a number to go by here. So now that I've got the number that Mathcad has calculated, let's go ahead and check it. So how would I check it? Well, I would go in and create a function that uses all these coefficients. So I'm going to call this test x shift semicolon. So this gives me 15810 plus, that'd be minus 107485 times x plus 304204 times x squared. Whoops, that fingered some button that, crap. X squared minus 458626 times x cubed plus 38833 times x to the fourth. Oops, cursor's not in the right spot. Plus, that's minus 175074 times x to the fifth plus 32827 times x to the sixth. All right, so now let me put my 0.85 in there. It equals, and I've got a bus somewhere. So, oh, okay. So what it is that it's round off error. So instead of putting in all these coefficients, if I'd have put those in, then I would have gotten the same number. But you know, this is really tedious, and unfortunately, every time you did this, if you had a six-sided polynomial or the factor x, then that would be a problem. So let's see if we can't come up with a little program to do this a little bit more efficiently. So one of the things is that I think I talked about earlier is that if the tolerance or the origin is 0 or 1, that can make a big difference. So I need to write a program that sets up both of a way to calculate regardless of what the origin is, whether it's 0 or 1. So let's let the program figure out if it's set at 0 or 1 and make an adjustment. So I'm going to type an index, and I'm going to see if I can get the last MGS, and I need to get one of these columns. Let me go to my matrix operators. I don't need a row, I need the column one, and I'm going to try column 1. Now it's real important that I don't put column 0 in there, because if the origin changes from 0 to 1, then I'll get an error message. So let's pick something that doesn't matter whether the origin is 0 or 1. I should get an answer. And let's see what I get here. Okay, 7. So let's also, to pick picked another index based on the length, MGS. Let's go back up here to the column, and let's also use 1. And see, so that gives me 8. So that tells me that my origin is set at 0. If I set it at 1, then I should get not the right answer, but the same answer for both of them. So let's create a little function. Let's call this capital T test. Shift Enter. Now I need to create a program. So I'm going to hit my little programming toolbar. And since this is a summation of a product that I'm actually creating, I'm going to type the word sum, and I'm going to set that equal to 0. And so that's the first thing that I have to do. And so now I have to give it an if statement. So I'm going to type in if, and so I need to let it know if I is less than J, then it needs to do something. So I'm going to create a for loop right here. For, and I'm going to come up with another index, K, which is an element of 1 to some value. And in this case, the value is going to be to I. And so now I need to put in my sum. I need to use my assignment operator, and I'm going to sum this vector. I'm going to hit the brace next to the little P sign, and this is going to be K, comma 1. And I need to multiply that times X, and I need to raise that to a power, and the very first power has to be 0, because then X raised to the 0 is X equal to 1, so that doesn't change my summation. So in this case, I'm going to call it K minus 1. Okay, so that takes care of the first loop. So I'm going to hit my space bar a bunch of times, and then I hit enter, and now I've got another if statement. And so I've only got 2 choices. So either I and J are going to be equal, or I is going to be less than one of them, because my only possibilities that I have for the origin is either the 0 or 1. So I don't really need to create an error message here. So I'm going to say else, well, let me just create that. Let me use an else if. Else if I is equal, and when I use equal, I have to use the Boolean equal, which is control equal J. You can find it here on this right there, control equal. So if I is equal to J, now I'm going to put another for loop in here. And this time I'm going to say for K in the range of, this time instead of being from 1 to I, I'm going to make it from 2 to J, and then I'm going to copy this and paste it, but I'm going to have to change this, because remember, I've got the very first X has to be raised to the 0 power. So if I raise an X to the K minus 1, in this case, K starts at 2. So K minus 2 minus 1 is 1, so that screws everything up. So I got to subtract 2. All right. So now this also has to change. So on my column, instead of being my first column, if I is equal to J, it's now my second column. So let me hit my tab over a few more times. Whoops, it's too many. Oops, one more time. There we go. And now I can either just type in sum, And see, I don't get an error message, so that's good. So let me go up here and type in test. And I'm going to use that same 0.85 and hit my equal key. And there we go. So that's basically the correct answer because it's using the actual values of these coefficients as opposed to a less significant digits. So I can delete. Well, let me check this thing before I do that. Let me go up to calculation, and if I did it correctly, I should get the same answer regardless of whether my origin is at 0 or 1, and in fact I do, so that's really good. That means that I've done this correctly. So now I can delete all this because it's not as accurate a way of doing it. Okay? And now there we go. All right. So that's I mean, it took some doing to figure this out and write it, but once I did, now I have it, and anytime I want to use this particular polyfit, I can come back in, check the answer just to make sure that the program's doing. And so if I were to, let's say, type in 0.9, 3.387, I should get the same answer when I do it here, and in fact I do. So everything's good. So let's move on. So I've done the power